This is Step Support Foundation assignment number 6. I highly recommend before doing this question, either just doing the prep section of this question in the booklet, or watching Eddie Wu's Permutations How to Account for Repetitions video. A really good video that helps you to do this question. I will go through some of what he does here, but I won't explain it properly like he does, because I can't really be bothered. I'm just going to breeze past it, but if you want more information, please do watch that video. This is the question here. We've got this number here, which if you add the digits up, sums to 17. And it's saying, show that there are 15 5-digit numbers, like this one, that instead add up to 43. Now, okay, let's just find a 5-digit number that does that. It's not too hard to find one. 9997 does it. And of course, 9 plus 9 plus 9 plus 7 is 43, so 99997 is a number that does that. Now, okay, apparently there are 15 numbers that do that. Well, okay, we could put this 7 wherever we wanted, couldn't we? We could, instead of having the number 99,997, we could have 99,979, right? We could swap the 7 and 9 over there. And there's clearly 5 ways you could do that, right? Just gradually shifting the 7 further and further to the left. So there are 5 numbers made up of 9, 9, 9, 9, and 7 that add up to 43. So where are the other 10 numbers then, if we've got 5 so far? Well, we can just replace this 9 with an 8, and then increase this to an 8, and we'll still add to 43. And then we just need to decide how many ways are there to arrange the 2 8s here. And again, just be very methodical with this. Put the 2 8s at the end maybe, and then move one of the 8s to the left, then move it to the left again, then to the left again. And then what I decided to do was start moving the other 8 further to the left until it caught up. And then, okay, well, after you've done these 1, 2, 3, 4, 5, 6, 7 cases where you've got either an 8 at the end or an 8 at the front every single time, then we just need to tidy up the middle cases where 8s are both in the middle, either here, like this, or like this. So that was me methodically thinking through how to get these 10 solutions here, which means 15 in total. Now, the thing is, you don't really want to do it like this every single time, because this is annoying to do. What we'd like is we'd like a system for finding how many arrangements there are of these numbers very quickly. And this is where Eddie Wu's video comes in, or the prep comes in, but I'll just explain it very quickly. If you have this number, how many ways are there to rearrange the digits of this number to have the same digits but just in different orders? Well, what you do is you take the total number of digits, so 1, 2, 3, 4, 5, 6, 7, do 7 factorial on the top, count how many digits are repeated 2 times, so there are 9 is repeated twice, and count how many are repeated thrice, or 3 times, I was just being fancy, well that's 5, and do 7 factorial, because there are 7 digits, over 2 factorial, because one number is repeated twice, times 3 factorial, because 1 is repeated thrice. So this number represents how many digits there are, this number represents a digit being repeated twice, and this number represents a digit being repeated 3 times. And this is going to be the answer. Now, a factorial is when you just times every number by the number below it, so 7 times 6 times 5 times 4 times 3, and so on. And so this is going to be 2 times 1, and this is going to be 3 times 2 times 1. And we can work this out in our heads, because we can just cancel a load of stuff. All of that cancels all of that. Sorry, I just cancelled that with that instead, actually. The 3's can cancel. This 2 can make this 4 into just a 2. Can't cancel it completely, but we can get rid of half of it. And now we just do 7 times 5 times 5, 7 times 6 times 5 times 2, but 5 times 2 is 10, 7 times 6 is 42, 42 times 10 is 420. So that's how we work this out nice and quickly. Now let's do another one. So this is a classic question. Every single university maths undergrad will be asked this question at some point. How many ways to rearrange the letters in Mississippi to make any word just with those letters? Well, you count the number of letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You say, okay, so that's going to be 11 factorial on top, that's how many letters there are. How many letters are repeated twice? Well, the P is repeated twice, there's one copy of the letter P, and then there's 4 I's and 4 S's. So this bit here is going to be 11 factorial over 4 factorial, representing the I's, then 4 factorial again representing the 4 S's, and then 2 factorial representing the 2 P's. Right, so total number of options, something being repeated 4 times, something being repeated 4 times, something being repeated 2 times. And this is a little bit harder to do, but it is still possible. Just do some cancelling, so this 2 and 1 goes away with that. Of course, the 1s are completely pointless anyway. This 4 goes away with that 4 there. This 3 and 2 can go away with that 6. 3 times 2 is 6, goes away with that. This 8 can go away with that 2 and that 4. And then finally, that 3 can go away with that 3. The 1s are pointless anyway, cancelled everything else out. This is a bit annoying to do, but it is possible. I think the logic that I used was 7 times 5 is 35, 9 times 11 is 99, and I liked that because 99 is not that too difficult to times. And then, of course, I've got just a 10 left over. Do these two first. That's going to be 350 times 99, which is just times this by 100 and then take away 1 copy. And we'll get our answer there eventually, which isn't too hard to figure out. So now that we've gone on this little detour, let's finally finish off the step question then. How many 5-digit numbers sum to 39? So, okay, we need to find a base case that sums to 39, and the easiest way to do it is to jam 9s in there until you're left with just the remainder. So 4 9s are 28. 4 9s are 36. 3 more gets you to 39. Now, how many arrangements is that? Well, clearly there's 5. You just move the 3 over. But of course, you could say there are 5 factorial, because there are 5 numbers, divided by 4 factorial, because one number repeats 4 times. Which, of course, is just going to be 5, because this will just cancel with everything except for the 5 on top, and you get 5 left over. Now, what about the other options? Well, just like in the first part, decrease this number by 1 to increase that number by 1. And we get this. How many ways are there to arrange that? Well, again, 5 numbers. And we've got 1 repeated 3 times. That's going to be 5 factorial over 3 factorial. You can do the maths if you need to, but this is the 3 times 2 times 1 up here. Are going to cancel with that, leaving you with 5 times 4, which is just 20. Again, keep going. So maybe decrease this again to increase this one. And again, the more systematic you are doing this, the more easy it is to not make a mistake. So notice how I'm just going to gradually make one no more different than the previous one. This is clearly going to have the same number as this did, because all I've done is change some digits, so that's still going to be 20 of them. Do it one more time, except if we do, we're going to get 6 and 6, which is going to be slightly different, because now we've got 5 numbers, 3 repeats, 2 repeats. So 5 factorial over 3 factorial, 2 factorial, which is only 10 of them, because you divide by another 2, essentially, to get this. Okay, now we've run out of things to do here, because if we decrease that and increase that, we'll just get this case. So we can't do that, so now we need to decrease this 9. So I've decreased this 9, and I think I don't know what my logic here was, to be honest. I think I've just jammed in as many 8s as possible, is probably what I did. So yeah, I'm jamming as many 9s as possible until I get down, and then as many 8s. I think that's my logic. So this is going to be 5 factorial over 2 factorial, 2 factorial, representing the repeats. And just keep going. I'll explain it less and less as I go on, because I'm sure people can just pick up where I'm doing from here and do it themselves from here. That one has quite a lot of options. Keep going. Again, jamming as many 7s as possible this time. Replace the last 9. And then finally you get to one last case where you don't have any 9s, and there's going to be 5 of those. Add up all of these numbers, and that is how many total things you have as the answer. Anyway, thank you for watching, and I'll see you next time.